Hello, everyone. Have you ever wondered why we measure angles in the way we do? Well, let's begin with the origins of trigonometry. The word trigonometry comes from the Greek words trigon, meaning triangle, and metron, meaning measure. So, trigonometry literally means measuring the sides of a triangle. Originally, this concept was created to solve geometric problems, especially those involving triangles. This was quite helpful for ancient sailors navigating across vast oceans and even surveyors mapping new lands. Over time, though, trigonometry evolved. Today, it's used in areas as diverse as seismology, designing electrical circuits, predicting tides in the ocean, studying the state of atoms, and even analyzing musical tones. It's all around us. In earlier math courses, we studied basic trigonometric ratios like sine, cosine, and tangent, which are based on right-angled triangles. But in this chapter, we are going to generalize those ratios to all angles, not just acute ones, and extend them into something called trigonometric functions. Sounds exciting, right? Now, let's talk about angles. What exactly is an angle? An angle is formed by rotating a ray about its initial point. We have two important parts to an angle: the initial side, which is where the rotation begins, and the terminal side, which is where the rotation ends. And the point where both sides meet is called the vertex of the angle. Angles are measured based on the direction of rotation. If the rotation happens counterclockwise, the angle is positive. If the rotation happens clockwise, the angle is negative. We usually measure angles using one of three units: revolutions, degrees, or radians. Degrees are most common, where one full revolution equals 360 degrees. We can break a degree into minutes and seconds. 1 degree is 60 minutes, and 1 minute is 60 seconds. So, 1 degree equals 60 minutes, and 1 minute equals 60 seconds. But there's another unit called radian, which we'll focus on later. Radians are often more natural in math and physics, so understanding how to convert between degrees and radians is key. Now, let's talk about radians. A radian is defined as the angle subtended at the center of a unit circle by an arc of length 1. Imagine a circle with radius 1. If you take a piece of the circle that's 1 unit long, the angle it makes at the center is 1 radian. It's a natural way to measure angles because it directly ties the angle to the arc length. For a circle of radius r, if an arc of length L subtends an angle theta in radians, we can use this simple formula: theta equals L divided by r. This means the angle is directly related to the arc length and radius of the circle. For a unit circle, the circumference is 2 pi. So, one complete revolution around the circle is equal to 2 pi radians, or 360 degrees in degrees. This concept is fundamental because radians provide a more direct link to geometry and calculus. Now here's a cool connection. Every real number can actually represent a radian angle when you think about it in terms of the unit circle. We can map each real number to an angle in radians, whether it's positive or negative, by imagining the rotation around the circle. If you consider the point on the unit circle as the starting point, and if you rotate the line anticlockwise, you get positive real numbers. If you rotate it clockwise, you get negative real numbers. This gives us a way to think about radians as a smooth, continuous measure of angles represented by real numbers. So, radians and real numbers are closely related. And what's even more interesting is that angles on the unit circle repeat every full revolution, so if you add or subtract multiples of 2 pi to an angle, the sine and cosine values remain the same. This property makes radians especially useful in trigonometry. Let's now talk about converting between degrees and radians. We know that a complete revolution around the circle which is 360 degrees, is the same as 2 pi radians. So, the conversion formula is 1 radian is 180 divided by pi degrees, and conversely, 1 degree is pi divided by 180 radians. Let's apply this with an example. First, let's convert 40 degrees 20 minutes into radians. First, let's convert 40 degrees into radians. 40 degrees is pi divided by 180 multiplied by 40, which gives 2 pi over 9 radians. Now, let's convert the 20 minutes part. 20 minutes is pi divided by 180 multiplied by 20 divided by 60, which gives pi over 540 radians. So, 40 degrees 20 minutes is 2 pi over 9 plus pi over 540 radians. Another example, convert 6 radians into degrees. 6 radians is 180 divided by pi multiplied by 6, which gives 343 degrees 38 minutes 11 seconds. Let's now apply this concept with a real-world example. Imagine you're solving a problem where you need to find the radius of a circle. Here's the situation. You have a central angle of 60 degrees and an arc length of 37.4 centimeters. Let's find the radius. First, we need to convert the 60 degrees into radians. 60 degrees is pi divided by 3 radians. Now, we'll use the arc length formula. Radius is arc length divided by angle in radians. So, radius is 37.4 multiplied by 3 divided by pi. After calculation, we find the radius is approximately 35.7 centimeters. Let's quickly review what we've learned about radians. Trigonometry evolved from solving problems in geometry involving angles, and today it plays a central role in many fields like physics and engineering. We learned that an angle is formed by rotating a ray, and angles can be measured in degrees, radians, or revolutions. The radian measure is more closely tied to the geometry of circles, with 1 full revolution equaling 2 pi radians. We also discovered how to convert between degrees and radians using simple formulas. We explored real-world applications of radians, like calculating the radius of a circle from arc length, which comes in handy in many practical situations. And that's the foundation of how we understand and use radians in trigonometry. I hope this gives you a solid start. See you next time when we dive into the next part of trigonometric functions.